Good morning, everyone. Welcome to this morning's workshop, Data Cleaning with Python. Thanks to those of you that joined this morning, both in person here at Olin Library and on Zoom. So welcome. My name is Molly Webb. I am a GIS developer on the data services team here at Olin Library. And this workshop, Data Cleaning with Python, is part of our Data Lab series that we offer every semester, various topics every semester. So feel free to keep an eye out on the library events page for other sessions that we're going to be doing this semester and next. So first of all, when do I even want to attempt to use Python to do my data cleaning? And this is going to be kind of coming from my perspective here, but for me, whenever I get started with a data set, maybe a raw data set, and I'm trying to decide, okay, how do I want to handle this? The goal here is that we want our processing or our coding in Python to hopefully be faster or more efficient than doing something manually. Usually when you get really large data sets, like maybe many hundreds of thousands of records or maybe even millions of records, we know that some of the other options for data cleaning, like Excel, they kind of, will freeze up after about 70,000 records or so. They might be able to handle more, but sometimes you'll try to bring in a large data set into Excel and it'll get truncated off. So sometimes the data is just really too big to be handled in something like Excel. If you know that you're going to be bringing in certain data sets and you're going to be processing similar data sets over and over again, and you want to make sure that you record the steps that you've taken, Python is a great way to do that because our code is kind of self-documenting. We know exactly what we did. We can run the code over and over again. And so that makes it easier for our future selves to make the changes that we need to in the data set. Another advantage of Python or doing your data cleaning in any kind of coding language is that you do have that built-in documentation and reproducibility, which we know is really important when we're doing research. We always want to be able to repeat or let someone know what we did to arrive at a certain data product. And obviously, as you become more comfortable with Python, Python will, continue to become maybe your go-to the more and more you feel comfortable with it. Now, we know probably that we do have other options for data cleaning. We do have Excel, and we can do limited changes using certain text editors like Notepad, Notepad++, Sublime Text, TextEdit, any number of those text editors. There are a couple of free and open source or FOSS applications that are out there and really popular for data cleaning. There's an application called OpenRefine, which is kind of like a GUI-based or a drag and drop kind of text editor. There's the scripting language R in RStudio, which is a scripting-based data cleaning. And really, R and RStudio do so much more than just data cleaning. They do statistical analysis and data visualization. So lots of options when you're working with R and RStudio. There's a couple of licensed applications, Stata, SAS, Tableau Prep. These are all applications that you do need kind of an additional license for, but do have data cleaning capabilities. All right, so I'm just going to check the participants list here. I'm going to check the chat. I'm going to assume that since I haven't seen any notes from anyone, that everyone has been able to access that Google Colab notebook and the other workshop materials. So let's go ahead and switch over to that folder and take a look at what we're going to be working with during our workshop today. I'm going to exit out of my presentation and I'm going to switch over to that workshop. So this is what it's going to look like when you arrive at that page. If you're going to be following along in the workshop with me today, go ahead and right click on that workshop data folder and download just to get that file download started. That's going to be some of this tabular data we're going to start off with. And then the PowerPoint that I'm going through is available here, and then the Python notebook, which is where we're actually going to run the code. Okay, your Python notebook is going to look like this. So if you're not familiar with a Python notebook, Google Colab is one application that has notebooks available. There's also Jupyter notebooks, which you may have heard of. And also, if you are familiar with the GIS application, ArcGIS Pro, they also have their own notebook framework within the ArcGIS Pro project that you can run Python code on as well. So lots of different options. The notebook is great for instruction like this. It's also really great for kind of interactive development because you can chunk up your code into cells and run them one by one. And then you can also include text in the form of markup to kind of explain what the code is doing. And so I love using notebooks for instruction purposes like this because not only can I, describe the code as I'm going through it live, but then when you go back and look at this notebook later, you'll see that there's kind of instructions and explanations written for each chunk. To run the code, so we have some text cells here giving us some initial instructions. But to run the code, all you need to do is click on the little play button next to the code cell. It will run, and then you'll get a little green check mark here. Now, as I mentioned in my email, if you are going to run this code, you do need to be signed in to a Google account to be able to run this code. So before we actually get started with the code, I do want to give just a little background on Python in general. So we're going to switch back over to the slideshow. Okay. So when you install Python on your machine, it comes with 3 prongs of items along with it. There's built-in classes, which are essentially the objects that hold the data and information in our script. There's built-in modules. Oh, we've got someone coming in. There we go. We've got built-in modules, which extend the functionality of your basic Python coming into your script. This allows you to reach out to different pieces of your machine, different pieces of your system, and write code that interacts with those different pieces. And then there's built-in functions, which are the pieces of code that actually do some kind of work in our script. Going back to our classes are going to have properties, which are characteristics about the class, and then they're going to have methods which are essentially functions associated with a particular class. So these sample lists that I've included here, they're not complete lists. There's lots of different classes and lots of modules and functions that come along when you install Python. And everything that comes along when you install Python, we call that base Python. Now, setting the built-in stuff just to the side over to the left-hand side of the screen here, there's also a lot of third-party libraries. So this is different Python code that gets written by other people. They submit it to a repository, and then you're able to install that on your own machine to extend the functionality of Python even more. So when you install third-party libraries onto your machine, they're also going to come with their own classes, modules, and functions. Some popular examples, at least that I use almost daily in my work, are pandas, which is what we're going to be focusing on today, NumPy, which is for working with numbers, obviously, different mathematical functions, and then ArcPy, which is an API to let you access the different functionality within ArcGIS. Now, you should also be aware that on your computer, you can have multiple versions of Python installed. So here's a hypothetical computer here, and I could easily have a older version of Python, a Python 2 version with various libraries installed. I could have more than one version of Python 3 installed on my machine, each with different libraries. So when you are working with Python, it is important that you know which Python installation you are accessing. For this workshop, we only have one option. We're going to be accessing the Python that comes along with Google Colab, and so it kind of eliminates that issue for us for this workshop. But if you are running Python locally on your machine, make sure that you're aware that you could have more than one. So it's important to get to know that a little bit. A quick refresher on syntax. So when we're talking about classes and getting properties from a class, the syntax is usually the name of the class, or excuse me, the variable that represents the class, and then whatever the name of the property is. So if we have a data frame object, we can say data frame.shape, and that returns the property that is the number of rows and columns in that data frame. When we're looking at methods, the syntax is usually the name of the class, dot, the name of the method, and then open close parens and 0 or more parameters, which is information that we're passing into the method. So for example, we've got string replace, and the name of the string dot the function, the method name is replace, and then we have two parameters, which is the string that we want to replace, and then the second parameter is the string that we want to replace with. Just checking on my chat here. I'm seeing the question about which of the 3 versions are in the Google Colab. That's a really good question. Maybe we can take a look at that when we move to the notebook. Oops. Thanks for that. All right. And then function syntax, it's very similar to the methods. We're going to usually start with the name of the library, dot, and then the name of the function, and then 0 or more parameters. So one function that we're going to use today is the read CSV function that's part of pandas. So the syntax is pandas, the name of the library, dot read CSV, and then open close parens, inserting the name of the file that we want to open. So just a little syntax refresher there. Okay. So just a couple of tips when you are writing your scripts. And if you're already experienced with Python, maybe you already are familiar with these, but these just come from my own experience writing Python code. So when you're writing a script, I like to set all of my workspace paths and all of my variables right at the beginning of the script, so I don't have to hunt for them later on. So if I am inserting the name of a file that I want to read in, I'll insert that kind of right at the beginning. So then, you know, if I move my script to a different machine, or if I'm using a different file, that variable is right there. I don't have to scroll through all my code to find it. Depending on the size of your data set, I kind of like to do data cleaning processing to add columns as I work, and then right before I write it out to another file or maybe take it to a different application, I narrow it down to only the columns that I need, and then I write those out. A lot of times adding new columns is a little bit easier than changing columns in place. And so typically, you know, I like to go with whatever is easiest. So adding columns as I work and then paring it down. A couple of things to pay attention to. We definitely need to pay attention to data types, how Python is recognizing certain data, and then also pay attention to where your input files are coming from and where your output files are going. So just a couple of tips there. Finally, before we get started on our actual code, I just want to give a little background on the Pandas library in case you're not familiar with it. So The most common data structure that we see in pandas is the data frame, which is essentially just a in-memory table of data that will look something like this. So this whole thing is a data frame. The first column is going to be the index or the unique identifier for each record or each row. And then each one of the columns are considered a series. So a group of series together makes a data frame. All right. In the notebook, my email address is here. Should you have any follow-up questions afterwards, please do reach out. The first thing we're going to do is we're going to load our data files into the notebook. All right. So there's a few different methods of accessing files within our Collab notebook here. We can actually access files that are saved in our Google Drives. That is something that we can do. And I've provided some code down at the very bottom of this notebook to show you how you can do that should you wish to do that. But if we're just kind of casually working with files here, we need to actually upload them into our workbook. So I'm going to navigate over to the file that we downloaded, the workshop data file. That was downloaded as a zip file, so we're going to need to unzip this. I'm going to right click, and depending on what kind of machine you have, you may need to use extract all. You may have 7-zip installed, which I do on this lab computer here. If you're on a Mac, you're probably going to unzip with the archive utility. So whatever you have available to you, go ahead and use that application to unzip the file and access the CSVs within. All right, I'm just going to open this up. And we've got a handful of files here. We're going to take a quick look at what data is actually coming in these files. The first one I'm going to look at is the file sample survey data. These are all CSV files. So I'm going to open this up. I'm going to zoom in a little bit here so you can see it better. All right. And so this CSV here is essentially a listing of some hypothetical survey results. We have a case number identifier coming in, a city, state, zip code, and then also an income value. The next one I'm going to look at is the STL city population 65 plus. In this file, we've got a zip code, and then we've got we've got a numeric field that represents the number of population that are above the age of 65 per zip code. And then we have some other fields that tell us the percentage and the margin of error here. Okay. So we had zip code in our first file and zip code in this file. We're going to remember that. Okay, and then finally, I'm just going to open up one of these NAICS files. They're all the same. We just have multiple files here. And zoom to this. Okay, so this file is pretty big. It has a lot of columns here, but what each one of these records is a listing for a business that has the business code of grocery store. So we're looking at records for a bunch of different grocery stores here, and we've got the business name, we've got a physical address, and a zip code. And then the key thing that I want to show everyone here that we're actually going to be working on is if you scroll all the way over, it gives us a bunch of different names of the executives for that particular grocery store. So I'm just scrolling. I think there's like 200 columns in this CSV, so it takes a little while. But here we have the names of the different executives for this business, and they're all on the same record. So we have executive 1, we have executive 2, executive 3, and so on and so forth. Okay, so just kind of keep that in mind. That's going to pertain to what we're going to look at as part of our data cleaning process. All right, I'm going to close up those documents. So now that we've taken a look at the documents, we need to load them into our notebook. So over on the left-hand side of our notebook pane, we've got a couple of different icons here. The top icon is our table of contents icon. So if you expand that, that's going to show you the different chapters in this notebook. So you could easily navigate to the different chapters if you want to jump around. We've got a little search and replace if we wanted to search and replace in our code. Once we start saving variables, all of our variables are going to be showing up in our variable list. And then this icon here is our file input output area. So I clicked on the file icon, and then I'm going to click on this upload to session storage icon here. This is going to allow me to navigate to those files that we downloaded. I'm going to highlight them all and click open, and they're going to start uploading here to our workspace. I am getting a warning message here that just says, once we close this workspace, these files are going to essentially go away. So make sure you have your files saved somewhere else. Don't just rely on this notebook to save your files. So if we have any output files, they're also going to appear here. So we want to make sure that we download those off of our notebook before we close it so we can save all that. Just a couple other things in the notebook. We have a little code snippet interface here. If we have something specific that we're looking for, there's a bunch of sample code snippets, which can be pretty helpful. There is a command palette that will run different commands. So usually I like to go through and I'll type in clear and clear all outputs. This just means that anything I printed out in my previous run of the notebook will be cleared out, so I have kind of a fresh, clean space. And then there's a little icon here that is kind of a premium feature to open up the terminal. So we're just going to kind of gloss over that because we're using the free version here of Google Colab. So my files are loaded here. That's great. Now I'll be able to access them in my script. So moving on to the next section, we are going to be using a combination of both built-in Python libraries and third-party libraries today. So for the built-in libraries, we're going to be using the OS library to get information about our machine. We'll be using the regex or re library because we're going to be looking at some regex pattern matching a little bit later on. And we're going to be using the date time library for working with dates and times. For third-party libraries, we're going to be using pandas and numpy here. Now, just a note that if you were using Python locally on your machine, pandas and numpy would need to be installed separately apart from your script. But in the Google Colab environment, those libraries are already loaded in. So all we need to do here is import them into our script. And we're just going to start with these first three. We'll import the other ones as we need them. This is mostly just for instruction purposes. Again, usually when you're writing a script yourself, you want to import all your libraries right at the beginning. Okay, so like I mentioned before, all we need to do to run these cells is just click the little play button and they're going to run. So I'm going to click this first cell to import the libraries. And then this second cell is going to specify the name of our files that we're going to bring in. So we're going to start with data file 1, which was our sample survey data, and we're going to access that just using the file name. We could also access the second CSV, the 65 plus CSV, by bringing in the file. But I also wanted to show you that we could bring bring in this file using a Google Drive link too. So I have this same file saved to this Google Drive link, and so we're going to use that to bring in the data, just so you have another example of how you can bring in data into your notebook. And then for the third file here, what I've specified is just the kind of prefix of those 5 files that are the grocery store files, because what we're going to do is we're going to loop through our files, and we're going to tell Python to only bring in the files that include this prefix here. So we're going to do that later on, but we're setting all of our variables here right at the beginning. All right, so I'm going to run this. Now, going to the question that our friend had on the chat, how can we tell what version of Python this Google Colab notebook is using? Well, so I'm going to do this a little off the cuff here. So to do that, we do need to have our sys library installed. So I'm going to go ahead and say import sys. I'll show you how you can add a new cell here. It's actually really easy. I'm just kind of hovering in between 2 cells, and I can choose to either add a code cell or a text cell. I'll add a code cell. And then so let's see if we can quickly get this information here. I'm going to try and print sys.version. And let's see if this can tell us some information here. Okay, so what this is telling us is that this notebook is using Python version 3.10.12. It's also telling us that this version is current as of June 11th. That's when it was released. So just a couple of months ago, that's fine in terms of Python versions. So we did need to import an additional library here to get that information, but this is one of the ways that we can see what Python version our script is using. So thanks for that question on Zoom. I appreciate it. All right, so we ran our cell to get our file names. Now let's go ahead and bring in some data. So like I mentioned at the beginning, we're going to be using this read CSV function to read in our data. Now, when we brought in our libraries here, I said, okay, import pandas. And then for the rest of my script, I want you to refer to pandas as PD. That kind of just shortens our code a little bit. So you can see here that instead of writing out pandas fully, I'm just saying PD to access everything within the Python library. So we're going to use the read CSV function. We're passing in the name of our first file here, and that's going to output a data frame that we're just going to call data. So we'll run that. It should run pretty quickly because the file is not that big. And then whenever I bring in a data set into Python, I always like to do a little exploration just to make sure I know what I'm dealing with here in terms of the size of the data set and the columns and all that kind of stuff. So a couple of helpful things that will let you do that. First is the shape property. This is going to output a tuple that gives us the number of rows and the number of columns. So we've got 1,068 rows here and 5 columns coming in. If we want to just take a look at the first couple of rows, we can use the head function. And by default, that's going to give us the first 5 rows in our data set, just so we can kind of look and see what we've got going on. All right, so that all looks fine. If we use the count method, that is going to give us the number of non-null rows for each column. So we can see that most of the columns have non-null values for all of the records, but in the income column, it looks like we do have some null values there. So that's helpful to know. The describe function is going to essentially gives us some information on the columns that Python has assumed are the numeric columns here. Ironically, both case number and zip are actually not numeric columns. They're categorical in this case, but since they have numbers in them, Python has recognized them as numbers. And so, we know, like, for example, taking the mean of a zip code really doesn't make a whole lot of sense, but this is just one function that you can use to get some additional summary stats on your numeric data types. If you run describe but include the parameter include equals all, this is going to do that same kind of summary statistics on all of the columns. And we'll see that some of the ones that it recognized as text values, for example, city, they're giving us nulls for the mean and the standard deviation because, again, text values aren't going to have a standard deviation associated with them. But that's just a way to get some summary info for all of your columns. Okay, and then we can do the same thing, and we can say, okay, I want you to only include columns of a specific data type. So if I want Python to give me summary stats on just the object, which a lot of times your mixed data types will come in as the object data type, we can say include equals and then pass in a list of the data types we're looking for, and that will give us the same kind of information for those. So here's telling us, okay, here's all of the essentially text values that it's found, the number of unique values, the top occurring value, and then some frequency for that top occurring value. So just a little kind of help on how we can first understand the shape of our data before we get in and start making changes. All right, so in this project here that we're working on for our workshop, there's a couple of different requirements we need to do to get the data ready for our analysis. I don't exactly know what the analysis is, and it actually doesn't matter in this context. Let's just say, here's what we've been told we need to do. All of the zip code values need to be strings. The income value needs to be numeric. We saw at the beginning that income was actually not coming in as numeric. It's coming in as a textual data type. We need to make sure that all of our city names are valid names and that they're consistent. Meaning, like, we want to only have one way of referring to the city of St. Louis, one way of referring to University City, and so on and so forth. And then also we know that for this particular data table, we want to join it to our second data table that has the data by zip code on the population. And so we want to make sure that this data table is ready to be joined to a second data table so we can match those records. So this is our goal for the first section of the workshop. Okay. So first, let's take a look at the data types coming in for each column. We kind of got a little clue when we were looking at the describe function, but if we use the data type, if we look at the D types property of the data frame, it's going to tell us what Python is initially recognizing all those data types as. So case number and zip are coming in as integers. City, state, and income are coming in as objects, which means the mixed case. All right, so the very first thing we're going to do, since our zip code column is being interpreted as integers, we're going to convert it to a string. So what we're going to do here is we're going to essentially replace the data zip column. So to specify a specific column in a data frame, you use the name of the data frame, and then in square brackets, you put the column name as text value. So wrap it in quotation marks. And so what this code is doing is it's saying, I want you to essentially replace the existing data zip column with the values coming in from the zip column converted to strings using this as type method right here. So as type, we're passing in one parameter, which is string type. So change those to strings. I'm going to run that. I'm going to look at my data types again, or my D types. And now I can see that zip code has been transformed to a string. Okay, awesome. So item number 1 done. Check. Now let's take a look at the income column. So we know that the income column is being interpreted as a mixed data type. But since we're talking about income, we want it to be numeric so we can look at it as a number to do our analysis. So the first thing I kind of like to do is just take a look at all of the values in this column. So what we're going to do here is we're going to start off with a for loop. So we're going to say for each value represented by a V in, and then this is specifying the data series income here. So we're saying, take a look at our income column and find all of the unique values of income. And then I want you to just print those all out. So I'm going to just run that, and we're going to have a long list of values printed out. And, you know, there's too many to look at individually, but what I wanted to show you here was the values that are kind of like messing up our numeric strategy here. It looks like for some reason we do have a value of St. Louis coming through in our income column, which is incorrect. And then we've got none here, which indicates that we do have null values, which we knew because of our previous exploration. So I'm just going to scroll back up a little bit on my notebook here. And this is kind of a long string of values to have printed out in my notebook. So I'm going to right click in the middle of the cell and click clear output. And that's just going to clear out that output so I don't have to scroll through it every time I want to scroll back and forth. So we did see the value of St. Louis, and we did see the value of none. Now, null values are perfectly valid values, but we want to make sure that they're recognized as null values. So let's use the same method we used before, and let's use this as type method to convert the income values into integers. So again, I'm going to say, okay, take the income column here, and I want you to replace all the values in the income column with the same values. I just want them converted to an integer 64 data type. So I'm going to run that. And as expected, we're going to see an error here. So let's look at our error. So this is saying, okay, we cannot convert a float null value to an integer. All right, so we're going to need to kind of try to figure out a different way to convert these values to numeric, because obviously just using as type in 64 is not going to work for us. All right, so let's try again. Let's take data income, and let's use a different function that's part of pandas. So pandas.toNumeric, I want you to convert to a numeric value everything coming in from our income column. Let's try that. So I'm going to run that. Again, I'm getting another error here. And the thing that is holding us up in this particular line of code is the fact that we do have the value St. Louis, and it's saying, hey, I can't convert St. Louis to a numeric value. What do you want from me? All right, I'm going to give you an error here. All right, so let's go back to the drawing board. Let's try again, because, you know, errors are all part of the development process. We got to figure out how we can get around these. Okay, so the above code ran an error. What we can do is we can continue to use the numeric function, but if I went into the documentation for pandas, looked at the toNumeric function there, I could see that we can add an additional parameter to this function, the errors parameter, instructing Python what we want it to do when we come across any errors. So what the course value applied to the errors parameter does is that anything that's invalid is going to be changed to a null. And, you know, just in the context of my project here, that's fine. I don't, if the income value is not valid, I just want to remove it from my analysis because it's not going to help me later on. So I'm going to run this code. That ran without errors. Okay, good. And so now let's take a look at those unique values using the same method that we used before. We're going to use a for loop to loop through all of the unique values coming into from the income column. So let's take a look. All of the values here, we now have a .0, which indicates they are coming in as numeric. And then if I can somehow scroll through, I just want to double check that I am getting some null values here. One of these days. See if we can find, oh, there it is. All right. So I do have some nulls coming in. Nan, you may be familiar, means not a number, or it's just a way of referring to a null value. So great. I didn't see St. Louis anywhere in there, and it looks like everything has been replaced with null. Awesome. All right, again, I'm going to right click and I'm going to clear my outputs just to keep my workspace kind of relatively clean. So the next set of tasks we're going to tackle is getting consistent values. All right, so we know, if you're familiar with St. Louis City at all, if you go out to 10 people and ask them to describe or tell us the name of the city that they live in, you're probably going to get 10 different versions of the name St. Louis.
Okay, so let's take a look at all of the values coming through in the city column. Again, we're going to use our unique function here. And so in this case, what we're doing is we're saying, go to my data frame. This is a little bit different way of getting to that same series. So we're saying data.city, that's the name of the column. And then we're going to say unique. So in this case here, we can either just use the name of the column, or we can always put it in square brackets too, with the name as a string. Both of those things will get us to the same place. So I'm going to run this code, and what this is going to output is essentially a list of all of the unique names coming through in the city column. So we can see we've got St. Louis, ST space Louis. We've got St. Louis, the word Saint written out. We've got some instances of Kirkwood. We've got U City, and then down here we can see we have University City written out. We've got another version of St. Louis, ST period space Louis. And then we also have the value of Mo, which I assume means Missouri, and that is obviously not a valid city value, so we're going to have to take a look at that as well. All right, so we've got some work to do here in terms of getting all of our city names consistent. Okay, so let's go ahead and let's do U City first. So it is helpful to know how to create a new column in your data frame. Remember at the beginning I said that adding new columns often is kind of easier than changing stuff in place sometimes. So the syntax for adding a new column is pretty easy. All you have to do is reference the data frame here, and then again in square brackets, just put the name of the new column that you want, and then after when you're assigning the variable, just put the value that you want. So in this case, we're going to create a new column called country, and we're going to populate all the values with USA. This is just a little bit of practice to practice adding a new column. So if we run that, ran successfully, now we're going to look at the first few rows, and we can see that the new column country has been added in at the end of our data frame. Okay. So now we're going to use this new column creation method to correct the UCity city name. So here we're going to use the replace method that's associated with the string class. There's two important parameters that we need to use here. We're going to use the toReplace parameter, that's specifying the string that you want to replace, and then the value parameter, which represents the string to replace the replacement string with. Okay, so let's take a look at that syntax here. We're going to create a new column called city corrected. So we're using the same method we did in the previous cell to create this new column. Then we're telling Python, okay, here's what I want you to insert into the new column. I want you to take the existing value of the city column, and then I want you to run a replace on it. What do I want you to replace? So specifying the toReplace parameter, I want you to find all of the instances of UCity, and then I want you to replace it with the value of University City written out. Okay? So the original city column is going to stay the same, but we're going to have a new column that is city corrected. And it looks like I accidentally added a period there. Oops, I moved it. There we go. So city.replace. All right, let's run that. Now let's take a look at all of the unique values coming in from our city corrected column. Okay, there we go. All right, so we still have all of our different versions of St. Louis, which we know we need to deal with at some point, but we're only seeing the one value University City, so that means that our correction, our replacement went great. It replaced all of the values of U City with University City. Okay, we can check out these values in another way if we wanted to. This is just another way of kind of slicing and dicing things to check them out. We could create a new data frame that has a subset of records based on the city column. So we're creating a new data frame called U City, and then we are specifying a subset of the main data frame here. So we're using the square brackets. There's a lot of different ways of using square brackets, especially in Python or in Canvas. So in this case, we're using these square brackets to specify a subset of the data frame data. Now these square brackets here still specify the column. So let's take a look. So we're saying, take our data frame, and then within that, I want you to find all of the records where the city column equals UCity, and then this type here represents OR. It's the OR conditional. So OR, the city column equals University City. So this is going to give us everything from the city column that equals UCity or University City. It's going to create a data frame, separate data frame for those. So I'm going to create that data frame, and then I'm just going to run my head function here method to see the top 5 records. Okay, so we can see here in our city column we had an instance of UCity, but then in our city corrected column it got corrected to University City. So just looking at this little tiny sample, all of that looks good. So just kind of another way of checking your work. Okay, so another thing, yeah. again this line of code. Yeah, okay, no problem. And yes, I did kind of gloss over this double equal sign, so thanks for bringing that up. Okay, so when in Python, when we have a single equal sign, this indicates a variable assignment. So we're taking a variable uCity and we're assigning it all of the pieces of information after the equal sign here. So that's what a single equal sign in Python means. When we're looking for equivalency, when we're comparing two pieces and we want to know if they're the same as each other, that's when we need to use the double equal sign here. So what we're saying here is we're saying take our data frame, and then this first set of square brackets indicate this is how we're going to subset our data frame. And then what records do we want in this subset? That's what we put in our first set of square brackets. And so we actually have two things that we want to look at in our main data frame to subset into our city data frame. We have two criteria. We want to get all the records where city is equal to ucity, or that's what the type means here, city equals university city. All right. So, and if we have even more criteria, we can tack those even, on even more. So this is just a way of using these conditional statements to subset the records based on the values that exist in the city column. Does that make sense? A little bit clearer? Okay, cool. Thanks for asking. Okay. So let's go on to the next piece that we're going to check for here. We saw that we did have a value of Mo coming in, and Mo is not a valid city name. So let's take a look at the specific records that have Mo for the city name. So what this is doing here is saying take my data frame, and I want you to show me only the records where data city, the city value, is equal to Mo. Okay, so this just pops out. It turns out that there's only one record here with the incorrect city, and that's record number, case number 1059. And so it looks like really what happened here is just maybe some values were transposed, put in the wrong column or something like that. We see our income is null, so chances are this is the record that had St. Louis as the income value. So we've got some correction to do here because we got a state equals null, that's good, but we also have city. All right, so we're going to use the replace again, but in this case, we're going to do it without creating new columns. We're going to use the replace parameter to just replace this instance of Mo just in place. So take the existing value and swap it out with the new value. And so when we're using the replace function here, we still have the toReplace parameter and the value parameter. We're just adding this third parameter, which is in place equals true. Okay, so we're saying go to the city column in our data frame, and we're doing a replace. What do I want you to find? I want you to find all the instances of Mo. What do I want to replace them with? I want to replace them with the value of St. Louis, and I just want you to swap out the existing values here. In place equals true. Okay, so I'm going to run that. And now we're going to take a look at this specific record of interest here. So we know that it's case number 1059. So we can isolate just that record by saying, okay, go to my data frame, and then within my case number column here, give me everything where case number is equal to, using our double equal sign, case 1059. So if we run that, that's going to give us this tiny little output that's one record, and we can see now that our city value has been replaced with St. Louis. So no more city equals Mo, now we have city equals St. Louis. That's great. Okay, so since we know that method now, let's go back and let's fix all of those uCity values so that we know that the city column is going to be our absolutely correct city column. So we explored our in-place parameter here. We're going to use that using the same method we did for uCity. So let's take a look at what's happening here. We're going to go to our data frame and go to the city column. We're going to go through each record and we're going to run a replace. If the incoming value is uCity, then I want you to replace it with university city right now. And I want you to do this in place, meaning swap out the existing values. So if we run that, that looks good. Now let's take a look at the unique values in the city column again. And now we can see, again, we've got our St. Louis here, which we're going to deal with in a sec, but we've got Kirkwood and we've got University City. So we're on our way to having a clean city column, but we're not quite there yet.
We're going to move on to how you can kind of like take it up a notch a little bit when you're doing these replace operations. So for the St. Louis city values here, we could certainly use the same method and say, okay, find all the values of ST space Louis and replace them with ST period space Louis, find all the values of Saint written out and replace those with ST period Louis. We could certainly do that. But the more and more different combinations that you have, the kind of more robust you need your tool to be in terms of finding those replacements. So I just want to introduce you to regular expressions here, just so we can at least know that they exist and maybe learn a little bit about how we can use them. So regular expressions are essentially like using very, very robust wildcards, or some people call them wildcards on steroids. All right. And so if you're interested in learning more about regular expressions, I have a link here that you can look at some additional documentation. And then there's also a regex editor where you can try out different combinations to determine what you actually need. Regex is almost like a little mini programming language in itself. To use regex in our Python scripts, we do need to import the regex library. So that's just going to be import RE. This is a built-in library that comes with base Python, so you don't need to install anything else. But when you want to use regex in your script, you do need to use this import RE statement to get it into your script. So with regex, very similar to our replace string method, we need a string that we're looking for and then a string to replace it with. So I'm going to go back to our presentation here, and we're going to take a look at how we can find that particular pattern. Okay, with our regular expressions. Okay, so we're going to do a couple of different things here. All of the instances of St. Louis coming through do have the word Louis written out. So we can at least hold on to that piece and use that piece to look for the different versions of St. Louis. What we want to do is we want to say, okay, find all the versions of Louis that have anything in front of them, and then change that to ST period space Louis. That's going to be what we're going to land on as our final version of St. Louis, ST period space Louis. So this is the regular expression string that we're going to pass in. The second part here is just literally the string Louis. It's going to look for capital OUIS. In front of it here is how we're going to catch any other thing that's coming through before the string of St. Louis. So, and like I said, regex is kind of like its own little mini symbol type programming language. So the asterisk and the question mark here. Well, let's start at the beginning. So the caret at the beginning of the string means everything within these open close parens needs to be at the very beginning of the string. Okay, that's what the caret means. So then anything within these parentheses needs to be at the beginning of the string. So let's take a look at what's in our parentheses. The period here means any character. So any character that is before the word Louis, that's going to be a match for us. And then the asterisk and the question mark indicates any number of instances of the previous character. So there could be one character, there could be 50 characters. It doesn't matter how many characters we have before the string Louis, that's going to be our indication that this is St. Louis, and I want you to replace it with ST period Louis. Okay, so this is just kind of a breakdown of that regular expression pattern that we're looking for here. If you're not quite understanding what that means, don't worry about it. I have it written down for you here. Definitely take a look at some of the documentation and maybe start a little bit simpler. But this is just kind of a way to just dive right in with learning regex. Okay, so what we need to do is we need to say, okay, here is the pattern that we're looking for. So we're creating a variable called STL pattern, and we're going to use the regex compile method to essentially insert that as the pattern that we want to find. And so for the compile function, we're passing one parameter, and you can see that this string here is the exact same string that we were looking at here. Okay, so I've just taken this string and I've pasted it into our code as a string. So here's the little caret, and here's the period, the asterisk, the question mark, and then space Louis. All right, so this is translating that pattern into something that can be used as the pattern we want to replace. So I'm going to run that. And so now STL pattern, that variable, is holding this string. So now I'm going to go down to the next cell, which has our replace function, which we've already used this a few times, so we're already familiar with it. It's going to be the same thing. We're just going to add an additional parameter to it to tell Python, I want you to use regex here. Okay, so we're going to say, go to our data frame, go to the city column, and find and replace these values. What do I want you to find? I want you to find the STL pattern that I just compiled right here. When you find that pattern, what do you want to replace it with? I want you to replace it with the value of ST period space Lewis. That's going to be our consistent St. Louis spelling. Okay, now here's the key for regex here. We're going to set, there's a parameter called regex, and we're going to set that to true. That means the pattern coming in, I want you to read it as if it's the regex pattern. All right, so regex equals true, and then we'll do this in place equals true. So go ahead and just replace these values right over the top of the existing values. Okay, fingers crossed. Let's run this and see what happens. Okay, so I got my little green check mark. Now let's see if it actually ran in the way that we wanted it to. Okay, so now when I use my unique function and I say, give me all of the values of the city column and give me all the unique values, I can see I've got 3 values here. I've got St. Louis, I've got Kirkwood, and I've got University City. Awesome. So now I have a nice, clean city column, and that is ready for whatever my next piece of analysis is going to be on those values. We're going to go on to the next section, which is joining tables. All right, so we did some work, we cleaned up our existing table, and now we want to join this table with our population data that is giving us essentially the population by zip code of people that are over the age of 65. So we're going to take our survey data and join it to this other data table. Okay. So the first thing we need to do is we need to bring that table, that second table, into our notebook here. And so, like I said at the beginning, we could just say, okay, here's the name of the CSV. I want you to read that into my notebook, just like we did with the first file. But here, I just wanted to show you a little bit different way of how you can access this data. Okay. So let's just, again, refresh our memories with the data file name 2 that we specified at the beginning. So it's this Google Drive document here that links to that 65 and over data set. Okay. So what we're going to do is we're going to use this URL to actually build the download URL of this file. And then once we insert that download URL into the read CSV function, instead of downloading the file, it's actually going to read the file into our notebook. Okay. So if you're not familiar with kind of how Google's URLs are built, every item has this unique ID here. And so that comes in this long string of kind of jumbled characters. That is the, after the file D and then all of this business. This is the unique ID of this particular item. So what I want is I want to try to isolate this unique ID so I can insert it into a download URL. So I'm going to take advantage of this split method here. So when you have a string that has consistent characters and you want to break up the pieces of that string, you can use split to break those pieces up, and the output is going to be a list of each piece of that string split at that particular character. So we're going to create a new variable called URL split, and we're going to take the existing data file name 2, which is this URL right here. We're going to run the split method on it. The split method is going to have at least one parameter because we need to tell Python, I want you to split it at all of these forward slashes here. So that means that this is going to be one section, this is going to be another section, this is going to be another section, and so on and so forth. It's going to split it at those forward slashes. So let's go ahead and create that string, that split that string, and let's take a look at the output. We're just going to print it out here. So I'm going to run that. And so the output here is a list. I know it's a list because of the square brackets. It's removed all the forward slashes and just given us all the pieces of information in between those forward slashes. Okay, so I know that this unique identifier here is always going to be the second to last element in my list. All right, so I'm going to use an index identifier to retrieve that last piece. Okay, so I'm going to take that last piece and I'm going to insert it into a new URL, which this is the beginning of all the URLs for Google Drive for direct downloads. And so what it wants is it's going to go to Google Drive and it's looking for this ID, and we're going to pass this ID into the URL by looking back at our URL split list. And then this index -2 is saying, okay, go to the end of my list and go 2 places in, and that's the element that I want you to pull. Okay, so we're gonna, and then the plus sign here is just going to concatenate those 2 strings, push them together. And then we're going to print the URL just to make sure that it looks okay. So let's run that. We have a URL here. Just to test it, I'm going to go ahead and click it and see how something started downloading on my screen. This indicates to me that that my URL is correct because I started kind of automatically downloading this new CSV. We're not going to use this download version. That was just for a test. We're going to pass this URL into our read CSV function, and that's going to automatically go out and grab that data and read it in as a pandas data frame in our notebook. Okay. So we're going to use that that read CSV function again, the same one that we use to read in our normal CSV. Only in this case, we're going to pass in URL, and it's going to go out. It's going to essentially download that data and read it in as a data frame. The new data frame is going to be called demographic data. So after we read it in, putting demographic data here is just going to print out that data frame underneath this cell. So I'm going to run that. Okay, that looks great. It looks like it ran. We have some data here. We've got zip code. We've got our population 65 plus, and then the other columns here. So that all looks good. If we scroll down to the bottom of the data frame, it looks like we had about 29 records in that data frame. Okay. All right, so I'm just going to do a right click and clear output just to clean up my data frame, or clean up my notebook a little bit. So the data frame's read in. Now let's take a look at the zip code column coming in from that new data frame. Okay, so here's just the values from zip code coming in. And if I scroll down, I can see that the data type was recognized as an integer. Okay. All right. So we need to do a little bit of work because we know that in our first data frame, we converted that zip code to a string. And so in order to do our join, the 2 data types need to be the same. We need to join a string to a string. So let me clear my output again here. And next, we're going to do the same thing that we did before. So what we're going to do is we're going to create a new column called zip. Now note that we're creating this new column called zip, and the column in our first data frame was also called zip. This just kind of makes it a little bit easier when we do the joins. And then we're going to take the value coming in from zip code and we're going to convert it to the type of string. So let's go ahead and do that. So now we have a column in our second data frame that's called zip code that has all of our zip codes by string. So now we're ready to take our first data frame and our second data frame and merge them or join them based on the zip code column. So that means that the record in our existing data frame will find the record in our new data frame, and it'll apply the values that match into one main data frame. And we'll take a look and see what that looks like here in a sec. But first, we're going to talk a little bit about joins, because joins are also something that's really important when you set out to do any kind of data cleaning or bringing tables together or whatever. So let's look at our joins here in our presentation. Okay, so imagine I have two tables here. I have table A, which is a table of authors that has a unique identifier for each author, first name, last name, and then a category. I've got table B, which is a table where each record equals a book. So we've got the title of the book, we've got the price, and then we have an identifier that represents the ID of the author that wrote that book. Okay, so two simple tables, A and B. Now, there's a few different types of joins. So a left join means that all of the records in table A will be returned, and only the records that match from table B will be included. All right, so we're keeping all the records from table A, and then only the records from table B that match on the identifying field. A right join is the opposite. We're going to keep all of our records from table B and only include the records from table A that match on the join field or the identifier. So it's kind of the opposite. An inner join is going to be only the records that completely match in both tables. So if there's not a matching record in table A or B, then that record will not come through. And then full outer join is joining everything. So all the records from table A will be included and all the records from table B. So let's take a look and see how these join types work using our little sample example tables. Okay, so first off, we're going to do our left join. Okay, so we're going to take table A and do a left join on table B based on the ID field. And the output is going to look like this. We're going to have all of our records from table A coming in. But for this author here, Emily Stevens, there were no corresponding records in the books table that corresponded to this ID. So now we have nulls here where our book columns or our table B columns were brought in because no records matched this ID. Okay, the right join is going to be the opposite. So we have all of the records for table B coming in, and some of the records matched from table A, but for this particular record, author number 26878, we did not have a corresponding record in the authors table for this ID. So the author information here is coming in null because there was no corresponding match in our authors table. Okay. The inner join means just the records that matched were included. So we only have we have all the columns here from A and B, but we only have 3 records because only those 3 records matched in both tables. And then for the full outer join, we're going to have all the columns again, but we can see that for this record, there was no corresponding records in table B for this author. And then for this book here, there was no corresponding records in the author table for this author ID. So that's what the full outer join means. Okay. So that's just a little refresher on join types. So now let's actually put those joins into action. So we're going to be using a left join here. Okay. So, and to do joins in pandas, one of the popular methods is to use this merge function here. And the merge function takes at least 2 parameters. It wants to know, okay, what is our join column, or what are we going to use to match these records? In this case, we're going to use zip code. And then what kind of join do we want? So in this case, what we're going to do is we're going to use a left join. We're going to keep all of the records from our first data frame, and then only join the records from our second data frame that match. Okay, so we're going to say PD merge. What do we want to merge on? We're going to merge the data frame with the demographic data frame. So this is going to be the left table and this is going to be the right table. What are we going to merge on? We're going to merge on zip code. And then how are we going to do it? We're going to do a left join. The result is going to be a new data frame called data with demographic. So let's run that and we'll take a look at these records. So data with demographic, listing it here is going to essentially print out the whole data frame. But since this data frame has over 1,000 rows, it kind of just shows us the first several and the last several records. So we can see here that so for our top record, the zip code 63122 did not match any records in our second data table. But the second record, zip code 63108, did match some records in our second data frame because here are those values coming in. And so again, 63122, no matches, but in these two zip codes, 63130 and 63110, those both matched records in our second data frame as well. So we can see we've got the null values here, which is expected. Those mean that there were no records in our second data table that matched the zip code in our first data table. So that's how we can kind of, bring two data tables together on a common field. All right, so far so good. We know we have some real values coming in. That's great. We also know that we do have kind of a lot of null records here. So, we could do just maybe an inner join just to get those matching records in, or we can take this full data frame and then we can isolate the records, only the records that matched. So for this, what we're going to do is we're going to use a little method here called not NA, and that basically will pull out any records that are not null. So we're going to call this new data frame join matches. We're going to take our existing data frame, data with demographic, and what are we going to do? We're going to isolate, or we're going to subset some of the records in this data frame. We need to specify, okay, what do I want you to subset with? What are my criteria for subsetting these records? So we're going to go to the data with demographic data frame. We're going to take a look at the zip code field, which is the zip code field that came in from our new second data frame. And we're going to say, give me all the records where zip code is not NA or not null. That's going to give us everything that was matched, because all of these null records are going to go away and we're only going to have the records that matched values. So we're going to run that and then we'll take a look at that data frame. All right, so now when we take a look at this data frame, now we can see all of the columns from our second data frame are all filled in. And so this gives us all of those matched records. It looks like there was about 50 of them there. Okay, so just a couple of different ways of doing the same thing. Again, we could have done an inner join that would essentially give us this same process. But for me, I kind of like to see, okay, what's coming in as null? Why are they null? Why don't they match? And maybe look at that a little bit before I go ahead and isolate all my records that actually did match. Okay. So finally, after we've done all of this data cleaning, we may want to write this data out to a local file. Maybe we're going to import this into another application to do some other kinds of analysis. And so writing out files is really easy in Pandas. We're going to say, okay, this is going to be the name of my output file. We're going to call it survey join to demographic data.csv. And then all we have to do is just take the name of our data frame and use the toCSV method associated with the data frame and pass in the name of the output file. And that's going to give us a new file. So let's go ahead and run this. After we output that file, if we go over and expand our files list here, we can see we have a new file, and we can even double click on that file, and it gives us a little preview here in the notebook. So just taking a quick glance, this looks okay. The only thing is it did print out an additional column right here to show us the index value of these rows. And honestly, I actually don't need that for any of my analysis, and I want to keep my data frame as clean as possible. So I'm going to close this tab. I'm going to go back to my notebook. And so what I'm going to do is I'm going to set the index parameter of that output to false. That means do not include that index column in the output. So I'm still running the same command here, join matches to CSV output file, but I've added this additional parameter, index equals false. So I'm going to run that again. It's going to save a new version of that CSV. If I double click that, now I can see that that index column has gone away, and that looks a lot cleaner for me. So also I'm seeing that I still have this city corrected column here, which was kind of like our working column that we didn't want, or that we were using to just show some examples. So I'm going to go back, I'm going to close this. And this time I'm going to say, okay, don't include that column in my final output. So what I can do here is I am saying, okay, I've got a variable called call list, and this is going to be a list of the columns in my join matches data frame. And we're just going to print that out so we can take a look at it. Then I'm going to take that column list and I'm going to use the remove method here to remove the column called city corrected. And then I'll print out my column list again, just to make sure that I did remove that. Then once I have my updated column list, I can insert that as the columns parameter into my toCSV method. And that's going to only take the columns that I'm specifying here in my column list and output those. So let's run this so I can see, here's the first columns that came in, and I can see city corrected here. Then I'm going to print that again after removing city corrected, and I can see city corrected is gone now, which is exactly what I want. Now I'll do my output, making sure to include the columns equals call list. So we're passing in this list of columns here into our output file. So let's run that. Let's double click our file again. And now if I just scroll through the columns, I can see that my city columns column, or my city corrected column, is gone. All right. So this is just a way that you can kind of like keep your outputs nice and clean. We don't need a ton of extra columns there. We'll narrow it down to just what we need so we can pass that on to our next application, whatever we happen to be doing with this data. All right, so now we're going to move to these 5 files here that, if you recall, are our grocery store information. Okay, so first thing we're going to do is we're just going to take a look at the files that are in our existing workspace. So essentially these files right here. I'm going to close that just so we have more real estate for our code. So what this is doing is this is just using a for loop. It's using the OS list dir function, which essentially goes to whatever the current workspace is for this Python script, and it's going to list out all of the files in that current workspace. So I'm going to just run that, and I can see now all of these files came through. They're kind of like in a weird order, but that's fine. So it's just looping through all these files, and I can see I've got my NAICS files right here. So remember at the beginning when we set the string NAICS underscore 4451 to the variable of data file name 3. Now we're going to take advantage of having that string saved as that value there. So what we're going to do is we're going to create a new list called flist, or that's going to be our list of files. And we're going to loop through the files just like we did in the previous code block. But in this case, we're going to put a little conditional statement here, an if statement that says, if the data file name 3 value, which is this NAICS value, is in the name of the file, then I want you to append that file name to our file list. This is just going to give us a list of those files that we want. Okay, so I ran that. Now let's print out flist and see, and I can see now that only those 5 files are coming through in my file list. So I can use this to tell Python, I only want you to bring in the data for those 5 files. Okay, so the next thing we're going to do is we're just going to take a look at the shape of those incoming files. So we're going to use a for loop to loop through all the files in our list. we're going to create a little temporary data frame called this DF by reading in the records from that file. And then we're going to print out the name of the data set and the shape of it. So essentially it's going to loop through each one of these files and print this stuff out for each file. So let's take a look at that. Okay, great. So here's the name of the file. And so for this file, this has 100 records and 228 columns. All of them are the same with the exception of the first file, which instead of having 100 records actually has 200 records in it. Okay, so just kind of a good way to get context for the files coming in. So then what we're going to do is we're going to use a pandas function to essentially take that whole list of files and read them into a single data frame. So let's take a look at what we're going to do here. So starting with this second portion here. So what this is I want you to take our list of files here, and I'm going to have you perform this function on all of the files. That's what the map function is doing here. So it's saying, go through my file list and read in all those CSVs. Thank you. Then what I want you to do is take the result of that, and I want you to concatenate them all into a single data frame called data combined. All right. So again, we're using our map function and we're passing in, what do I want you to do? I want you to read in the files. What do I want you to do this function on? I want you to do it on the list of files coming through in my F list. Once you have all this information, what do I want you to do? I want you to concatenate all of those mini data frames into one larger data frame. So that's what's happening here in this function. The result is going to be data combined. Let's take a look, see what that looks like. Okay, so my code ran without errors. Awesome. Let's take a look at the shape of that combined data frame. Okay, so I can see that I've got 600 records now and 228 columns. That matches up with the individual files that came in. So that's 600 total there, and we've got 600 records. Let's take a look at the first few records from our data frame. Okay, so there's all that. Since we had so many columns, you can see that it kind of just is giving us the first several columns and then the last several columns, and then all of the other 200 plus columns are just kind of being truncated there just for this output, but we still have 228 columns there. We can take a look at all of the columns, the names of the columns, by running the columns property. And again, here's all of the columns at the end of the data frame. Here's all the columns at the beginning. But this list was so long, it just kind of truncated them. If we wanted to actually look at all of the individual columns, then we could use a for loop and loop through all of the columns and print those out in this way. All right, but we can see that that list is very long. All of these different columns here. Okay, I'm going to clear that output. Okay, so now that we have our combined data frame, we're going to do a little bit of manipulation here. So the first thing we're going to do is we're going to add leading zeros to a string. So if you are familiar with working with zip codes, you're probably familiar with the fact that some zip codes actually start with a 0. Especially when you're talking about locations on the East Coast. There's a lot of zip codes that start with 0. So a lot of times when Python or any computer application really brings in a list of zip codes, sometimes it looks at those values and it says, oh, those are all numbers. And so it will essentially eliminate those leading zeros because a number can't really start with a 0. And so when we're dealing with zip codes as categories, we need to add those leading zeros back in. So the physical zip column in our new data frame is what holds that zip code value. So let's take a look at that. We've got some values coming in. We can look at all of the unique values of zip code coming in. There's lots of them here. And we can see that. Okay. So we have all of the unique values of zip code listed here. And we can see that there are some zip codes that only have 4 digits. And so that means that we need to add a leading zero to all of these zip codes with 4 digits so they can be recognized as the actual zip code that they are. So I'm going to clear my output here. Okay. So the first thing we're going to do is we are going to create a new column where we convert the values from the existing zip code column into strings. So we've done this a couple of times before. So we're just taking our combined data frame and we are going to apply a new column called physical zip string. And we're going to use our as type string method to convert those values. Okay, so I'm going to run that. Now, when I look at the unique values here, I can see that they're coming in as strings. We've got our little single quotes there, which gives us an indication that this is a string value. The next thing I'm going to do is I'm going to look and see, do we only need to add like one leading zero, or are there some values that maybe need 2 leading zeros? I'm not sure because there was a lot of different values. So I'm going to take a look at the minimum length of all the values coming in and then the maximum length of all the values coming in. So what this is doing here is it's going to my combined data frame and it's looking at the column physical string zip or physical zip string. And then it's taking those values as a string and it's getting the length of each one of those values. Then all of that is happening. And then I go to the min value here, and I want you to output the minimum value of all of those string lengths that came in. Max is doing the same thing. It's just finding the max instead of the min. So then I'm going to print out the minimum string length and the maximum string length just to see kind of what I'm dealing with here. So I'm going to run that and I can see that the minimum string length is 4 characters and the maximum string length is 5 characters. So that just gives me an indication that we have some zip codes that need a single leading zero. Now, the cool thing that we can do with this is that Python has a great built-in string method called zfill. And so all you need to do, which specifically adds leading zeros to strings, which can be really handy. So all you need to do here is you need to call the zfill function and then insert the number of characters you want that string to have. So what I'm doing here is I'm creating a new column called physical zip string 5. This is going to indicate our 5 characters. I'm taking in the existing physical zip string coming in. I'm setting that as a string, and then I am going to use the zfill function to pass in any leading zeros that need to be passed in there. So I'm going to run this. And I'm going to double check my min and my max. Now I should be seeing 5 for both of these. Okay, there we go. And if I look at the unique values of physical zip string 5, we should be seeing some leading zeros here. Let's see if we can see any. Okay, well, we're not seeing any there. Let's print out just the unique values here. Are we seeing any? Okay, here's one. So I just printed out the unique values. Since there's so many, it's just giving me the first few and the last few, but I can see that there is one value here that was 1460 and now coming in as 01460. So our leading zeros have been applied. Awesome. Okay. Okay. So, you know what I'm going to do here is I'm just going to skip over this next section because this gets into splits a little bit more. And we did kind of hit the split section before when we first read in our second data frame there. So this is essentially just reading in values, splitting them, and then applying them to different columns. And so since we kind of hit split a little bit, I'm going to leave this right here for you to look at individually, or if I have time at the end, I might head back to it. But I want to make sure that I at least get to this date section and then hopefully the reshaping section that's next. Okay, so if you've worked with dates at all, you know that dates and times can be a major pain. No application ever seems to read them correctly. No application ever seems to want like a consistent format. Every application seems to want their own unique format. And so working with dates and times can be really frustrating sometimes. So we're just going to do a little bit of work about working with dates and the hope that maybe it might make your life easier later on. So Python does have a built-in date time module. Again, this comes with base Python, but you do need to import the date time module into your script if you're going to use this extended functionality. So I'm going to run import date time. And so in our data, one of the fields that came through was the year established, which was the year that whatever company was, incorporated or established or whatever. If we say we want to know how many years this company has been in business, well, we could certainly just take the current year, 2023, and subtract the year established, and that would give us kind of like a rough estimate in integers, what the number of years in business is. But we can take a look and take advantage of the date time functionality to get a more precise number here and say, and have Python working with dates and subtracting values from dates instead of just integers. So we've got the year established column, which is coming in as a float. And so the first thing that we want to do is we want to convert this float value to a date time so that Python knows, okay, this is actually a date that we're talking about here, not just any old random number. So we're going to create a new column called established date. And we're going to use the toDateTime function here to convert everything coming in from year established into a date. And we need to pass along a specific directive here or a specific date format. So we need to tell Python, okay, what can you expect this date to be coming in as? And this %year means you should expect a 4-digit year to be coming in to this new field. And if you click this link here, this is a little bit more information on how you can format those dates, because there's a bunch of different options in terms of specifying what format a date is going to come in as. So after we run that, let's take a look at the date, what's coming in as the date. So when we do that switch now, that conversion, now all of these years are coming in at something that looks much more like a date format. And for now, it's just saying, is putting everything to be the first of the year. All right. But the important thing is it is being recognized as a date. We can see that right there. Okay. So now let's create a new column that's going to create a date time object for today's date. That way we can know how many years this company has been in business. So Pandas has a function called timestamp. And if we say timestamp.today, that just is going to retrieve the value of today's date. So we're going to create a new column called current date, and we're going to populate it with today's date. So let's run that and let's see how that looks. Okay, great. So that's all coming in as today's date. Awesome. Okay. So now what we're going to do is we're going to subtract those two dates using the time delta function. So if we take a current date, or if we take today's date and we subtract another date, that's going to, using the time delta function, that's going to give us the number of days or years or whatever we want in between these two dates. So we're creating a column here that is years in business. And to find that value, what we're going to do is we're going to, let's start with this chunk here. We're going to take the current date, which is today, and we're going to subtract the established date. Then from here, we're going to say, I want this value in years. So we're going to divide it by the time delta of 1, and then the Y here represents 1 year. A little bit more information on finding the difference between dates. You can look at the NumPy date arithmetic documentation there for some additional information. But essentially what we're doing here is we're getting a value that is the number of years. It's getting the difference, and then it's transferring that to years. Okay, so let's do that calculation, and then we're going to take a look at those values. Okay. So great. So now we can see we're getting a much more precise value here. And just looking at our first record here, a little under 9 years, we can see that our first record was 2015. So that makes sense. 2023 minus 2015 is going to give us this 8.7 value. So years in business, there you go. Okay, and so I think the last thing what we're going to do here, and the reshaping tables thing is going to have to be something you're probably going to address on your own, or if you are interested in reshaping tables, send me an email. Maybe we can take a look at it together sometime, but just in the interest of time, we'll wrap up with trying to determine if a date has already passed, which can also be a helpful thing that we might need to know sometimes. Okay, so another column that was coming in as part of our data frame was an obsolescence date. So the company that compiles this information, essentially they put an obsolescence date on these records so that they know, okay, when do we want to get these records updated? So we want to see if the obsolescence date has already passed. So the first thing we're going to do is we're going to take the obsolescence date here. We're going to create a new column called obsolescence date, and we're going to use our date time conversion again. The only thing is we are going to be looking at it in a little bit of a different format here. So the obsolescence date, if we run this, let's see what the date's coming in as. So the date was coming in as this 4/15/2022. So we've got 2-digit month, 2-digit day, 4-digit year, divided by forward slashes. So when we're converting this to a date, we're going to tell Python to expect this date to come in as a 2-digit month represented by the % lowercase m, a 2-digit day represented by % lowercase d, and then a 4-digit year represented by % capital Y. So Python's going to be like, oh, this is what I'm expecting for the format. Now I know how to convert these dates into actual date time objects. So let's run that. Okay, great. So now we have dates that look kind of like the consistent date format. And then all we need to do here is see if the current date is greater than the obsolescence date. And then that will tell us if that date has already passed. So we've already put current date in as a column called current date. And then what we've done here is we've created a new column called date needs updating. And so if the current date is greater than the obsolescence date, then that value is going to be true. And this record is going to need to be updated. Okay, so once I run that and then I print that out, I can see all these records came in as true. Okay. Okay, so just a little preview of what the reshaping the tables code actually does, and then feel free to go through this when you have some extra time. I'm going to go through our presentation here. So if you recall, when we brought in these new data frames, we had one record for every company, and then all of the executives in that company were all listed in the same record. So we had executive 1, executive 2, executive 3, executive 4, all the way to executive 20, actually. So say we're doing some analysis on executives, and we want to have a data table that is only these executives and their position and whatever, their names and etc. So instead of having a very wide table with multiple columns in the same record for each exec, we want to make a very tall column or a tall data frame that has the company ID and then each executive for the company in its own record. So the process goes like this. We have our wide data frame. Then what we're going to do is the code goes through and it separates out those executive names into their own data frame. So we have a first name data frame, a last name data frame, a gender data frame, and so on and so forth. Each one of these data frames keeps the company ID, so we can link those, we can always link those back to the company table if we want. And then using that same kind of concatenate option there, we can melt all these data frames back together so that the data frame ends up being a very tall data frame instead of wide. So for our example here, I'm just showing you how the 3 records that were going across the same record are now 3 records all linked by company ID in that tall table. Then here's the second company, here's the third company, and here's the fourth company. So the code in the notebook goes through and it kind of walks you through how you can separate each one of those out. And it culminates in using this melt function right here, which melts all those data frames back together. So if that's something that you think might be helpful for your research, feel free to go through this, and you can always reach out to me with any questions if you have any trouble with this. So that brings us to the end of our time. Let me go ahead and just say, if you have any questions or if you want to attend any of these other events that we're doing, go ahead and visit us at the library.wustl.edu website, or you can send me an email. And my email is included here at the top. Please stay in touch. If anybody has any questions, I'm happy to field those now. Else, really appreciate you joining me here on Zoom and here in person. Thank you so much. And hope to see you again at another one of these workshops. So thank you.